Hello everyone. Today we will be solving the fourth weekly contest. There were four questions in it. The questions were rooted function, integer replacement, random peak index, and evaluate division. Let's go to the contest page. Okay, and let's solve the first question. All the four questions were pretty good. So let's try to solve them. In the first question, we are being given a nums array of length n, and what we have to do is we have to perform function f on each position. So first we have to multiply 0 with the first element, then 1 with the second, till n minus 1 till the last element. So let's try to understand it with the example. If nums array is given us as 4, 3, 2 and 6, so for evaluating f of 0, we need to multiply 0 with 4, 1 with 3, 2 with 2, and 3 with 6. And if we sum it up, we will get 25 as our output. For evaluating f of 1, we have to shift the mask, that is 0, 1, 2, 3, by one position. So 0 would come at the end. Rest of the elements 1, 2 and 3 would be like 1 into 4, and then 2 into 3, 3 into 2, and 0 is multiplied with the 6. If we sum up, it would evaluate to be 16. After that, we would evaluate f of 2, which would be equal to 0 into 2, because it should move 0 by 2 positions. So 1 and then 2. And it will give 0 into 2 plus 1 into 6 plus 2 into 4 plus 3 into 3. And which would come out to be 23. And if we evaluate f of 3, it would come out to be 26. And we have to return the maximum value of every f of value. So the answer should be 26, which is the maximum. If we look at example 2, there is only one value. So if we move 0 at any other place, there is no other place, and it would just give 0 into 100, that is 0 as our output. Okay, so to understand the logic, let me subtract both equations, that is f of 1 with f of 0. So f of 1 minus f of 0, what will it give is 0 into 6 minus 3 into 6, and then the another element will be 1 into 4 minus 0 into 4, then 2 into 3 minus 1 into 3, and 3 into 2 minus 2 into 2. So we can write 1 into 4 minus 0 into 4 as 1 into 4. After that, another element would be 2 into 3 minus 1 into 3. So 2 minus 1 is 1, so it will again give us 1 into 3. uh, Another element would be 3 minus 2 into 2, so 1 into 2. And the last element would be 0 into 6 minus 3 into 6, so 0 minus 3 is minus 3 into 6. And we can rewrite it as let's call it 6 minus 4 times of 6. So why are we doing it? Because we can previously see that every number is multiplied by 1 except for the position, which is the new position of 0. So it would be again like 1 into 6 minus 4 into 6, which will give us minus 3 into 6, which is same as 0 minus 3 into 6. So we can rewrite it like this as well. And why am I doing this? Because I can see a pattern over here. So this is nothing but just the sum of every elements of nums, that is 4 plus 3 plus 2 plus 6, and the last element which is subtracted from the overall value is the position at which, no, the number of elements in the array, that is 4, and the position at which the 0 is shifted to, that is 6. That is 0 is shifted to this position, so 6 is multiplied with the number of elements, And to evaluate f of 1, we can move f of 0 on the right hand side, and we need to sum every elements minus number of elements into position of new 0. So nums of n minus 1 for this case. Yes, this equation, through this equation we can evaluate the next f value. So if we want to check, we can check it for f of 2. So how we can check is f of 2 would be equals to f of 1 plus sum of elements minus n into nums of new position of 0. So what would be new position of 0? That is 2. So nums of 2, that is n minus 2, and what it will come out. So f of 2 would be f of 1. F of 1 as we evaluated, that is 16, plus sum of all elements, that is sum of 4 plus 3 plus 2 plus 6, that would give us 15, and minus number of elements, that is 4, into position of new 0 is 2, 4 into 2, which would be equals to 16 minus 8 would be 8, and 15 plus 8 would be 23. Yes, f of 2 is indeed f of 23. And similarly, if we evaluate f of 3, we would get 26 as our output, and the maximum value is 26, so we would have to return it. So okay, let's try to write the code for it. We need to sum every elements, and also we need to evaluate f of 0. So let's call it f of 0 equals to 0. We would run a loop through all elements in nums, and let's define n as well. Nums dot size. Okay, and what will be sum? Sum will be nothing but sum equals to sum plus nums of I, and f of 0 would be equals to I into nums of I. So 0 into nums of 0 plus 1 into nums of 1, similarly for rest of the elements. And to store the answer, let's call it final answer, and it would be equals to f of 0 initially, that is 25, and now we have to evaluate the next elements, that is f of 1, f of 2, and the initial value of the new index of this is 6, new 0. So what we can do, we would have to run a loop from I equals to n minus 1 till I greater than 0, because the last position which 0 can take is this one, because we have already evaluated this as f of 0, and we need to evaluate every value. So what new value is, new value will become is f of 0 plus sum minus nums of I, and our final answer would be maximum of both values. So maximum of f answer comma f0, and we would just return f answer. Let's try to run the code. Oh shit, there is some error. Let's try to see it. We are evaluating sum f of 0, and then final answer equals to f of 0. Okay, from n minus 1 to 0, sum would be equals to this a, not nums of I. It should be n into nums of I. So n into, let's put it into a bracket. So I think it should be fine. Yes, let's submit it. Yes. So let's try to solve the second question. We have been given a positive integer n, okay, and we have to apply following operations. If n is even, then replace n equals to n by 2. Okay. And if n is odd, we have to either replace it by n plus 1 or n minus 1. And we have to return the minimum number of operations needed to convert n to 1. Okay, got it. So if n is given as 8, which is even, so we just directly divide it by 2, and it will give us 4. 4 divided by 2, 2, and 2 divided by 2 is 1. So we require 3 division operations. So we have to return 3 for this case. For 7, it is odd, so we have to consider both the cases, that is n plus 1 and n minus 1. So 7 can be changed to 8, and then the same operations similar to this. For this case, 7 is changed to n minus 1, that is 6, and then divide by 2 minus 1 and this. Okay, so in both the cases we are only taking 4 operations, so we have to find a recursive code to solve this. Let's try to write the recurrence. Okay, let's let's create a solve function which would evaluate everything. So there are two cases, right? If n is even, so if n modulo 2 double equals to 0, then we just need to return solve for n by 2, or else we have two cases that uh, n can be replaced to n plus 1 or n minus 1. So we just need to return solve of solve of n plus 1 comma solve of n minus 1, and whatever it will give, you have to take the minimum value. And to evaluate the number of values, so we can add 1 to it. So what our solve will give is number of operations to cut from 8 to 1. So solve will return that. For 4, so solve will return for 4, so recursion would take care of it. And once we reach n, so our base case would be if n double equals to 1, then we just need to return 0, because 1 doesn't require any number of operations to reach to 1. So yes, you got the logic. Let's try to run it. But as it is a recursive code, I I believe that it would give us TLE, and I don't want it, so I need to memorize it, whatever you want to call. And we can see that value of n is pretty high, 2 raised to 31 minus 1, that is int max. So we can't create that much big vector to store just unnecessary values. So we need to create a map data structure, and int comma int. Okay, that is, we just are applying the basic rules for converting a recursive solution to a DP solution, and we have to store every value in map before returning it. So mp of n equals to this, and if we have previously visited it, so mp dot find n double equals to mp dot n, then we just return it mp of n if we have not previously visited it, right? So it should run fine, I believe. Okay, there is an error. What is it? Okay, I haven't called TP over here. But I believe that it would not store the value of this because when n plus 1 is called, so integer cannot store the value greater than int max. So I need to convert it into long or just long simply. And okay, long of this and convert this also into long. Okay, let's run it. Yes, so let's try to submit the code. Yes, it's running absolutely fine. But why is the complexity so poor? I don't know. Let's solve another question. Third one, random pick index. Okay, what we are given? We are given a nums array and randomly output the index of given target. Okay, you can assume the target number exists. Okay, implement solution class and solution will initialize an object of array nums and int pick equals to pick will give us a target value 3 and we have to find that at which index or yes at which index we are having the pick and we have to pick the index with equal probability. Okay, got it. So let's solve it. Okay, we can solve it like this as well. We need to first create a private variable to store a vector int nums. Okay, and whenever we are in the solution class, so this dot nums equals to nums. You can write it this way as well, but the mode preferred way is swap one because it somehow takes less complexity. So this so that we are using nums dot swap and pick function would work like this. We need to traverse through the array and whichever index is there we need to store it in a vector. Let's call it index and once we are traversing through the array nums dot size and if we find nums of I equals to target, so we just store the index of it. So index dot pushback I. Okay, very good. And once we get all the index position, we have to randomly select any one of this. So let's the length equals to index dot length and to return a random any random value. So we can do is index of random function modulo ln. So it will give a random value from any one of this. Let's try to run the code. Yes, it's running fine. So let's submit it. Also, another way we can solve this question is using a map data structure as well. Why I would do that? Because peak operation would take O of n time again, and what we can do is we can pre-compute while initializing the solution. So let's try to implement that as well. So we would create an unordered map of int comma int map. Okay? And what we can do, we need to store every index, right? So here it should be a vector because it can have multiple values and let's say it could be num size, and for every value what we can do is this dot index, not index, map of nums of I, and we need to push it into the vector, so push back the index. Okay, so now we can compute it in O of one time. So let's remove this, and here I have changed the variable name mp.size mp of this, but we need to write over here target of this. Let's try to run the code. Oh, giving runtime error. What we have done wrong? We are storing every value into this, and after that, once we are calling it length. Okay, so here we need to call mp of target because here only the 3 stored, so mp of 3 is only required, and yes, it's running fine. Let's submit it. Okay, and let's solve the last question, evaluate division. So we are given an array of variable pairs equations and an array of real number values, and equation of I is denoting ai to pi, and values of I represents division of it. Okay, so ai divided by pi is denoted in values of I, that is 2.0, and each ai and bi is a string. You are also given inquiries from C to D, and we have to find the answer of C divided by D. Okay, and if the single answer cannot be determined, return -1. Okay, the input pair is always valid. You may assume that evaluating the queries will not result in division by 0. That's cool. The variables that do not occur in the list are undefined, so answer cannot be determined for that. So for this example, if x is not in there, hence we are returning -1. Okay, let's understand it with an example. In equations, we have a to b, that is a divided by b is given as 2.0. B to C is also given, that is B divided by C is 3, and we need to evaluate for this values, that is A divided by C. So if we multiply A divided by B with B divided by C, both B would be cancelled out, and we would get A divided by C to be equal to product of this, that is 2 into 3 is 6. To evaluate P divided by A, we have to just make an inverse of it. So 1 by 2, that is 0.5, correct? From A divided by E can't be evaluated because E is not there in equations. Similarly, if we divide A by itself, it would give 1, and unknown variable is, that is x, is divided, but it was not defined, hence we just return -1 for this. So I guess you understand the question. How we can solve is, we can create a graph which stores the value of division from it, a directed graph whose edge denotes the division value of it. Okay, so let's say A is a point, and edge connecting from A to B denotes 2, that is division of both of it, and we also connect an edge from B to A which denotes 1 by 2, so which is 0.5, And while calculating A divided by C, there is an edge from A to B and then B to C. So we just product all of the values of edges and it should give the value of A divided by C. So yes, graph would work. So let's call a graph and we can just call another map as well. We can store the graph in another map for each string and string comma double. Okay, let's call it graph equals to, and we need to first build the graph. So this is the data structure of the graph and what it would require. Let's call the function build graph and the function would require every equations and values. So let's pass it from here and yes, should be fine. And we have to store it into this data structure, custom data structure. Let's call it PR. And while traversing through all equations, we have to find the value of dividend divided by divisor and store the value of values of I into it. Okay, so let's run a loop. Each equations dot size, and let's store each variable into a string as well. String of dividend equals to equations of I comma 0. Okay, and let's store the divisor as well. Okay, now we need to store the value of this. So double value equals to values of I. Okay, now into the graph. So graph of string comma string. Okay, so you can consider it as a 2D vector, but we are using an ordered map for this question. Equals to val. Okay, and the reverse of it, that is the reverse edge from B to A, store 1 upon val. So let's write it as well, 1 upon val. And once we are finishing by storing all the values, we can just return the graph. And let's directly call the function over here, build graph of equations comma values. Okay, our graph is created. Now we have to traverse through the queries and find out each values. So let's store it into an answer variable and run a loop from all queries. Let's directly write it like this, iterator of queries. Okay, and our first value is dividend, which would be find out using string of, let's call it dividend only, it dot first. Okay, indexing. Okay, and string divisor, it dot second. And what we can say is if it is not present in the graph, then we just written -1. So if graph dot find of divisor or dividend, and also we can write it for divisor, graph dot find of divisor is equals to graph dot end, then we can just push -1 into the answer, correct? Or else we can traverse to the graph. So for traversal, we can use any of the traversal method. I would say I would use DFS. So I would call DFS for dividend, comma divisor, comma graph, and we would need a visited set as well. And to store answer, let's store it in temp answer, and I think it's enough. Let's store it into a set of double string. Okay, and also let's define answer, temp answer as well. Let's initialize it with -1. Also, we would require a variable which would keep multiplying all of this. So let's another variable temp as well. So double temp to 1.0, because 1 into the edge width would return 1, and after computing the DFS, we would store it into our answer, then answer into the answer. Once we are done, we just return our answer. Now we need to write the DFS for it. So let's write it. So many parameters we have to write. So let's start string dividend, string final destination, and then we would require a graph. Let's directly take it from here. Graph, and would require a set that we have created. Is set visited, okay, and two double values, temp answer as well as temp. We are passing temp answer by reference because the final answer should be stored. Okay, and let's think about the base case. If we reach, if our current node reaches to the destination, then we have to return the answer. So if this is happening, then we would return, but before returning, we can store the final answer. What was the name? Temp answer equals to answer. Okay, DFS function would be like, first write all the base cases. Let's write all the base cases. Also before it, we can check if it is previously visited, then we just don't need to visit it again. If visited dot find if not equals to visited dot end, so this means that we have already visited it and we just no need to traverse it again. And every time the else case is there, so visited of div would be equal to true. That is, we can say we have to mark it visited, right? So visited of div, or we can just insert because it's a set div. Okay, so we have written all the pieces. Now what we have to do is we have to traverse through the edges, each edge, right? So for each edge, let's write it like this: iterator on graph of current node, that is this, and we have to call DFS for each of that, that is first for it dot second. because graph will store the edge width, and no, I do that first because the corresponding edge is stored in it dot first, and destination and graph and visited and temp answer. Okay, not temp because we need to compute the value as well. So let's call it second into 10. And once we finish each value, we would be storing the answer in our temp answer. Yeah, I think it should run fine. Let's try to run the code. It's showing an error, grp in line number 21. I have stored gr. Let's correct it. There is an error in line 30. It dot first. It should be id of 0, right? Not id dot first. Let's run the code. Yes, it's running absolutely fine. I guess you understand the logic. Let's submit the code. Yes, 100%. Thank you so much for watching the video.